Now let us see this question. An air bubble of radius 2 millimeter is formed at the bottom of a 3.3 meter deep river. Calculate the radius of the bubble as it comes to the surface. Atmospheric pressure is this and density of water is given to us, right? So basically, this question is of a combination of thermodynamics plus fluid dynamics. So basically, what will be the difference between the bottom of a deep river and the surface? No, this is the river. And this is the height. It has a height of 3.3 meter, right? Now, what will be the difference? If I talk about, now it is saying the radius of the bubble. So how do we correlate the radius of the bubble to thermodynamics? If I see the radius of the bubble, that means if the bubble is there, that means some gas will be trapped inside it. So if we can use, this gas for our calculations, this would make our work easier. Now, gases, we obviously use kinetic theory of gases, right? So for gases, we know that it will have certain volume. So basically, radius is connected to the volume because volume will be given by what? 4/3 pi r cube, right? So basically, here is what? Radius is connected to the volume. But what about the height? So what happens when we go below the river? Obviously, the pressure increases, and what is the pressure? So P becomes equals to P naught plus rho gh. Am I right? So if at the surface, what will be the pressure? Now, pressure at the surface will be equal to atmospheric pressure, which is given by 10 raised to power 5 pascals, right? But the pressure at the bottom, B, would be equal to what? Pressure at the surface, which is 10 raised to power 5 plus rho gh. Now, rho of density of water is given as 1000, which is 10 raised to power 3. What is G? Let us assume it to be 10. And H is 3.3, right? So we will get this as 10 raised to power 5 plus 3.3 into 10 raised to power 4. So I can write this as 1.33 into 10 raised to power 5 pascals, right? Now if I see, now it is saying calculate the radius of the bubble as it comes to the surface, and the air bubble of radius is formed at the bottom. So at the bottom, the volume is given. So if we assume that the temperature is uniform, that means T1 will be equal to T2 equal to T. So, and the number of moles, obviously, of the gases in the bubble will be constant because no gas is escaping from the bubble. So I can very well say that P1V1 should have been equal to what? P2V2, right? I can use this equation. This means P1 would be equal to the pressure at the surface, which is 10 raised to power 5. And what is the volume at the surface? 4/3 pi r cube. Radius is that the radius at the surface, which we have to calculate, right? And this would be equal to P2, which is pressure at the bottom, which is 1.33 into 10 raised to power 5, right? And what is the volume at the bottom? It is given that the bubble has a radius 2 millimeter at the bottom. So this will be equal to 4/3 into pi into r cube. R would be equal to 2 into 10 raised to power -3, right? Whole cube, right? Right, so if we have to calculate this 4/3 pi, we can cancel out 10 raised to power from here, 10 raised to power 5 from here. So this will give me r cube would be equal to 1.33 into 8 into 10 raised to power -9, and this would be equal to 10.64. If we calculate 1.33 into 8, this will be 10.64 into 10 raised to power -9, right? Now we have to take a cube. So basically R would be equal to cube root of 10.64 into 10 raised to power -9. So if you calculate, you will get the value approximately 2.22 millimeter, right? So this will be the answer, right? So if you see, if you're looking at the solution, you might feel that, the question was very simple, but these kind of questions will be coming into IIT, or similar concepts will be coming into IIT, but you have to just take care that you have to write down whatever is given in the question. If you are able to figure out what is given and what needs to be calculated, you will easily get to the answer.